All right, everyone hear that okay? All right. I think we have time for a question. So does anybody have a question? Yes.
What's your favorite Python module, David?
All right, good question. Question is, what is my favorite Python module? I think my favorite Python module is basically the collections module. I mean, people use collections. If you're not using collections, you're just like missing out on like insane awesomeness here. There's a lot of interesting things in there. You might have used like ordered dictionaries or default dicts or other things in there. One of the more useful things in there, or maybe it's not. Well, I don't know if it's useful, but maybe a little bit more obscure is the deck object. If you haven't messed around with this, basically a deck is kind of the tool that you would use to build queues. It's kind of like a list that's optimized for doing queuing operations. So you can append things at the end of it, and you end up with something like a list, and then you can pop things off the front. And it's implemented in a way to be very efficient. It's actually a little bit better than a Python list for that. And this thing sort of underlies a lot of the kind of low-level parts of Python, especially related to concurrency and stuff. One of the things that you might do with a deck is actually build like a queue class. So if you wanted to build your own class, I'm going to make a class called Queue just because it sounds sort of ridiculous. I don't know, maybe like the name of a pet or something like that. Actually, on that subject, if you really want to annoy your kids, suggest like computer terms for the names of guinea pigs and stuff like that. Like, so I have I had my kid, and they're like, "Oh, Dad, what should we name the guinea pig?" And I was like, "Oh, you should name him Semaphore or something." And he's like, "Oh, God, it's like terrible." And then he's like, "Well, okay, he doesn't like Semaphore, so why don't you name him like Monad or something?" And then he's like, "If you suggest that again, I'm going to punch you," and so forth. So anyway, like you can build queues basically from a deck. So I'm going to start by just kind of building like a frame, like a part of a queue class here. So essentially you have a get, which you might take like a bunch of items here and do a pop left on it. Okay, so this is popping something off a queue, and then you'd have a put method, which would put an item on there. Maybe your queue has a maximum size. I'm going to do a little check for that. Like if the number of items is less than that, we'll go ahead and put something on the queue. Okay, so I'm going to append the item, and then if it's too big, I'm going to be very helpful and just print out no. Okay. We'll come back to that. Okay, so this is kind of the fragment of a queue, and assuming that I can type it right, there's always this danger of making like a syntax error there. So let's try that again there. So we're going to have this queuey thing that we're going to make, and essentially it's going to have like a put method on it, which will put things onto the queue, and then we'll have a like a pop method that takes things off. Oh, get method, okay. Queue get. Did I misspell it again? Or? Okay. Oh, yeah, okay. Okay, it's going to be a debugging session too. Okay, not even using like my okay. Okay, you get the idea. You're going to build a queue like that. Yeah, okay. Yeah, okay. Little glitches here and there. Okay. So you have that. It's always good to have glitches to say it's like it's not pre-recorded or something like that. Okay. So you have your queue here. Put stuff in there. Get stuff out. Okay. Good. Now, doing this. Okay. So you're looking at this like, why is he building his own queue? I mean, that's like a stupid thing to do. It turns out that queues are already part of Python. If you've done like thread programming or something, you might know that there is already like a queuing module in Python that you can use. Like you can say from queue import queue and get a queue object out of there. If you use that, you'll find that it has a put method and a get method and so forth. So you can put things on there and you can get things off. But one of the things that that the queue module has is it has a little bit of coordination between like the get and the put. Like one of the things that happens is if you do a get and there's nothing there, it's just going to sit there and kind of wait for something to show up. Okay, so the thing is like, okay, kind of hanging out. The only way that you're really going to get something to go in there is it's going to have to be inserted into the queue from another thread or something. So you're gonna have to work with threads. So the kind of thing that you would do is maybe, okay, I don't know, bringing a thread into the system. I'm gonna import the time module just to sleep for a second here. So what you might do is you would say, okay, well I'm gonna launch a thread where the target is some function where maybe I sleep for 10 seconds and then I do a queue put. By the way, if anybody ever complains that Python doesn't allow you to have multiple things in a lambda, just do this like little tuple trick that I'm doing here, and they'll get like really aggravated and annoyed probably at you there. So I'm launching a thread, and then what will happen is I'll do a get, and this thing is kind of hanging out, doing waiting for that thing to show up, and eventually like an item shows up there. So this is something that you use commonly to kind of coordinate threads. It's a very common tool of thread programming. Really, the kind of thing that you would use this for are kind of things like producer-consumer problems. So you might have a producer that maybe produces a bunch of items. This is kind of a dumb one, but what will happen here is this thing is going to put something into the queue. So put I into the queue. Maybe we'll finish up by putting none in there. That, I think that's, no, I'm missing a line, okay, for, like that. And then you might have a consumer that pulls things out of that. Just pull the screen down a little bit here, okay. So we would do like a while true, get an item out of the queue. Maybe if the item is none, we break out of that, and then otherwise just print that we got something. Okay, got item. So that's what we would start with, and then the way that you would use that is really something like this. You would pull in your threading module, like that. You could launch a thread saying your target is this producer thing, and maybe the args are the queue and 10. So let's go ahead and start that. Oh, let's see what's happening here. Oh, the R. Oh yeah. Okay. Yeah, I like a whole room of pair programming. It's awesome. Okay, and you have to make the queue first too. That. Okay, queue. Okay, so you have to make a queue. You have to import queuing. Oh man, I'm really digging a big hole for myself here. Okay, you can never.
You have to create queue again.
Okay. People are really wondering where this is going now. Okay. All right, target equals famous last words of it's like Okay, let's try that now. Okay, so now you run it, and then if assuming that this worked right, and I'm not a betting man at this point, I'm kind of actually terrified, to be honest, a little bit. You could launch the consumer, and then hopefully this thing will work. Okay, so we got consumer problem. Now, why am I talking about this? Okay, queue stuff. Well, one of the issues with this queuing business actually does concern this like blocking behavior. The fact that if you look at you try to pull something out of a queue, it just sits there and blocks. I don't really like that. So the problem here is blocking. That just seems like so 1990s, basically. Blocking. I mean, everybody's into this like non-blocking I/O and non-blocking stuff. It's like, why is the queue block like that? I mean, I know it's like the 1990s called once it's queue back, basically. I need some other thing. So the thing that I was going to think about a little bit here is I wonder if I could build like a non-blocking queue. You know, could we bring a queue kind of into the modern age and do like a non-blocking version of this thing? And if you could, what would that actually look like? I'm going to have like a get no block and a put no block. And one way that you might be able to build something like that would be to use the concurrent futures module. First of all, it just sounds kind of futuristic. I mean, you know, you got that. So what you might be able to do, if you haven't used that module, basically the key of it is there's this future object that you can use. And essentially a future represents kind of like a result in the future, okay? Hence the name. So the way that it works is if you ask it for a result, it will just sit there and kind of block. It's like, all right, nothing's around. And essentially what it's doing is it's waiting for some thread or some other piece of code to set the result. So if something later comes along and says, you know, does a set result on it, all of a sudden you can pick that up. Okay, so it's this object that essentially lets you kind of, you know, wait for a result, lets you set results. The way that you would use this typically is the same way that you would do this like threading stuff. Like you might launch a thread and it would set the result in the future there. Now, how I'm going to use this is I'm going to kind of maybe use this in my queue. So what I'm going to do in the queue is on this get method, I'm essentially going to say, well, if there are items to return, I'm going to return an item and none. We'll see what that none is about in a second. Otherwise, what I'm going to do is return none and then some future object. The thinking here is that if the thing doesn't have anything available, I'm just going to return this future. And I'm going to do the same thing in the put. So it's going to look a little strange, but let me talk about how this is going to work. So you're going to make like a queuey object here. You can put things into it. Like you can do a put no block and it'll just come back. You can do a get no block and it will come back with either the item and like none there. But if there's nothing available, like you do a get no block, it's going to come back with one of these like weird future objects. So it says, there's nothing there, but there's this future. The same thing on the put. So if you did a put no block, you know, you could put things in there. But then if you filled up the queue like that, it's going to come back with a future saying, well, okay, I don't know. It's like the queue is full. I got this future thing. Now, okay, that looks a little strange. I mean, it's like you got this no blocking queue, and it's like, why would you do that? I mean, that's just that's crazy. Here's kind of the thinking of how this is going to work. If you did this, like let's say you started doing like these get no blocks. Okay, you're going to get data coming back. How you might use this is you would essentially say, okay, I want an item and a future, like that. It would come back, and if you got that future object back, I need no block. So if you got that future back, and you had space, okay, so you get that back. If you got the future back, essentially what you could do is kind of wait on that, with the hope that like it would come back eventually. Like you're gonna wait on that future, like you would basically do like a result. And then you just kind of hang out, and you're going to hope that it shows up at a later time. So I'm going to take that idea and really kind of try to build it into my queue here. So here's what I'm going to do to kind of build this out. I'm going to make a list of getters and putters. These are actually decks of these, and I'm going to modify the queue slightly, where it's going to maintain those lists. So like if you're going to block, like this get is going to block, the queue is essentially going to make a record of that. It's going to say, okay, I'm going to keep a record that you're doing that. And I'm going to do the same thing down here. I'll make a future. I'll put it on that putters list there. Return it back. Okay, so I'm going to return these things back. And here's what that's going to look like. Still might be a little bit strange. You're probably thinking, where's he going with this? Here's how it's going to work. Make a queue. If you do, put Knobloch on it, you'll put an item in there. Let's do it a couple of times, like that. If I do it a third time, what's going to happen is it will come back with this future, basically saying, well, okay, I'm not able to do that right now, but it will sort of store the items. You got the 2 items there, and then underneath the covers, it's got a record that somebody's actually waiting to put. It's like, okay, there's this putter is kind of hanging out there. The same thing on the get. So if you do a get Knobloch, it's going to start returning items, and then when it decides to block, it's going to return this future thing back, and the queue will keep a record of that. So it's keeping a record that, oh yeah, there's this thing kind of waiting to get something. So we have putters and getters kind of coordinated there. It still doesn't quite work. I mean, what we've got right now is a little bit of just kind of machinery in play, whereas like this queue, it doesn't block, but it's keeping a record of who is blocking and why they're blocking. To get the thing to kind of work for real, I have to build in just a little bit of extra machinery here to essentially unblock the other thing. So like what I would have to do in the get is wait any kind of like a putter, basically. Like if there's somebody waiting to put into the queue when I'm about to pull something off, I will do that. So I could say, well, if there's somebody waiting to put, I'm going to basically pop it off and set their result. It turns out for the put, I don't really know what the result is, so I'm just going to drop like a true into the thing there. Okay, so we're going to wake a putter there. We're going to do the same thing here. Like if you put something on the queue, we're going to wake like a getter, basically. So what we're going to do is kind of take a look at that. Like if there are getters to get, I'm essentially going to pop one of those off, and I'm going to set its result actually to the first thing on the queue. So this might look a little strange, but I'm essentially waking that up, and I'm building like kind of little communication between the two, those 2 lists there. So here's how that's going to work. Let me just try it out here. We'll make a queue. Definitely have to call that QE. I think that's just like that there. So you'll do a put Knobloch, maybe put a few things on there, like that. If you do like a third one here, it's basically gonna return this future back, saying, well, I couldn't do it because the thing is full. So you're going to have items there. You're going to have a record of putters there. But if somebody takes something off, like if somebody were to take an item off of that, what would end up happening is that future that I created would actually get set to saying, well, hey, somebody pulled you off, and then the thing is kind of removed from that putters list. It's like, oh, okay, that thing is done. We can do a few get Knobloch here. Let's go the other way on it. So we do a get, we get an item. If we do that, we get this future object back. I'm going to save the result this time so you can see what happens. So this thing comes back saying, oh, it's pending. If somebody puts something onto the queue, you're going to see that future basically flip its state, saying, oh, somebody put a result in there. You can get the result doing that. Okay, so you've got this queue. It's kind of built on futures, and you've got this little kind of coordination going on. Now, you might look at that and say, well, okay, this is nuts. Like futures, like non-blocking queues. Where is this sort of crazy train going at this point? And the reason for doing this, well, one of the reasons for doing it is it turns out that you can re-implement the thread queue with this really easily. Here's how you can re-implement thread queues. If you wanted to do a get, what you can do is basically call this like Knobloch thing. You can say, let's do a get Knobloch. If you get a future back, you just wait for it. Okay, so you do a result like that, and then you return item. Okay, so it looks a little weird, but it's like you go to the queue and you just say, okay, I'm going to try it. If it's going to block, then I'll wait for the future to just kind of get the result and I'll return that. And then you can do the same thing for a sync method. You're going to do something like this, where I'm going to spin in a loop. I'm going to try to do a put no block on it with the item. It would help to have an item here. Okay, so you can have that. If this future is nothing, so if it's none, I'm just going to return. Otherwise, I'm just going to hang out and wait for a result. Kind of the idea on this last part is if I have to block, I'm just going to like sit around. If I get unblocked, I'm going to try it again until I can do it. So doing that, you'll actually find that all of this stuff that you did with the thread queue works. I mean, I have to change the name of the function. Like I have to use put sync and get sync and so forth. But if I've done this right, famous last words, I should be able to do like this threading stuff. So I should be able to come in to the threading module here. Let's load that. Let's make a QE here. QE2, and then I can QE2. Let's not go there. Yeah. Okay. Yeah. Okay. We make a queue there, and then okay, we'll launch the producer there. Okay, args is equal to args 10. Start. I'll do another thread where I launch the consumer. A little bit of panic here. Let's see if it works. Okay, so we got this communication between threads there. Because we're working with threads, and I'm a little tiny bit paranoid about this, I might want to put maybe like a thread lock on this too. I mean, it's you can never be too safe with it, so I'm gonna put a slight tweak on here and violate PEP 8 at the same time, probably. So I know it's like the 2 space indent. So I'm going to be yelled at the code review, basically, big time. They're going to say, what are you doing? You can't do that. Okay, so got this thing built up with threads here. Okay, so going down this thread queuing thing. Now, here's where this story is going to take kind of a weird twist. Okay, it's like, okay, got this thing with threads. I don't really want to talk about threads, really. What I want to talk about is async IO. Okay, so async IO, really big thing right now. Non-blocking, scalable IO, that sort of stuff. If you haven't used async IO, the main thing that's going on there is it executes these async functions. Like you can write an async function in Python and have it, I don't know, return like, I don't know, this is kind of a minimal example. You can have like a function async that just returns a name. I'm using an F string just to make sure that this never works on anything other than Python 3.6 too, so you gotta do that. And so if you haven't used async, it's a little strange. I mean, you have these async functions. One thing about the functions is they do not operate in kind of the typical way. Like if I say G is equal to greeting Guido, it just comes back with this coroutine object. It's like, all right, what's that? Well, here's kind of the things you need to keep in mind. So this is sort of rule 1 of async. Async functions don't run themselves. It turns out if you want anything to happen in this async IO world, you have to basically get like an event loop. I mean, something else has to run these things. So what you do is you end up getting an event loop. And then you have to type all this stuff out, like run until complete, and you give it this G, and it will come back saying, okay, hello Guido. So anytime you do anything in async IO, there's this other piece kind of in play. You gotta run an event loop. Another rule of async is that async functions can call other async functions. So how that might work is if I had an async function spam, for instance, and I had like names is equal to Guido and Paula or something, Louis, like that. Okay, let's say you had like had some names like that. You can write functions that iterate over that. But if you're going to call another async function, you have to use this magic word await. So you could do that. In order to get that to run again, you're going to have to give it to the event loop. Okay, so run until complete, and then you'd call spam on it. Okay, so you see the function basically running there. So that's the second rule of async, is like the functions can call other async functions, but you need that await function. One thing about await, by the way, that cannot be done just outside. Like I can't just sit there at the terminal and say await like spam Dave or something, because it comes back saying, what is this await thing? It's like that only works if you're inside async function. And then the third rule of async is don't talk about how it works. Okay, so you know, it's like if I tell you how it works, we're forget about it. It's like you know, actually I think the analogy on async, like if I were describing how a list comprehension works, I'm not going to open up the Intel 8386 assembler manual and start from there. That's kind of how I feel about async. It's like no. So we're not going to talk about how it works there. But there is a twist on this though. Rule 4. Async IO loves non-blocking. Everything about async IO is about non-blocking, non-blocking sockets, non-blocking IO, all this. It's like no, I mean it loves non-blocking stuff. And we just built this non-blocking queue. I mean, it's a little strange, but I mean, it's like, okay, we have this non-blocking queue. Do I even have that around? Okay, let me make this queue here. So we have this QE thing. I can come in here and say, okay, item future is equal to queue get Knobloch, like that. You get this future thing. Turns out that async IO knows how to wait on things like that. I mean, it can wait on a future. This is a core feature of async IO. It's a little bit cryptic how you do that. You know, there's a few sort of. Yeah, I gotta import those. Come on, Python, you're supposed to know what I want there. Okay, so you can import those, and you can write like a little coroutine, like you could say async def spam for instance, and then in that coroutine, I could do something like this. I could say item is equal to, you know, await, wait for, you know, wrap future or something. Okay, so okay, it's not the nicest piece of code, but you can do that, and then I don't know, let's print out like got item here. Okay, so got item. So you can do that. What I'm going to do to kind of make that work is I am going to bring in kind of the thread module for a second here. So I'm going to say, okay, let's do a thread. The target of this thread is going to be I want to sleep for a second here. So we're going to do a thread where the target is equal to you know, this magic lambda trick here. Okay, we're going to do a sleep for like maybe 15 seconds, and then I'm going to take the queue and I'm going to drop something on there, just using my sync thing that I had before. So we're going to do that, and then what I'm going to do is take the event loop and run that. So if this is working, well, famous last words, and kind of dramatic pause. We're going to see like 42 show up here in a second. Okay, so basically we got like a thread passing something through a queue over to the async IO side. All right, still with me on this? Okay. Right. There'll be a quiz later on where this is going. Now, knowing that, it turns out that we can take this queuing object that we made and kind of use that idea. Okay, I have to pull in a few imports here from Async IO, and what's going to happen is I'm going to write basically a async version of the get and the put. And the kind of amazing thing about this is it's going to look almost exactly like the synchronous one. Okay, so we're going to do the same kind of check. The main difference is that there's going to be this kind of weird async IO stuff. So we're going to have to do like a wait for, and we're going to have to do a wrap future. The none, by the way, is like a timeout. I'm not going to do a timeout there, but you can wait for that. And I'm going to do the same thing here. Okay, so we're going to do a put sync put async actually. Okay, make sure you have the name spelled right, and it's going to look essentially exactly the same as the other one. We're going to do this kind of non-blocking put. And then the main difference is just how we wait for this thing. So we're going to do this await statement where we have to wait for this this future to come back, like that. I think I've got the parentheses right. And if we've done this right, famous last words here, I should be able to write kind of the same Q code, but kind of in an async style. Let me see if I can do that here. I'm going to write like an asynchronous consumer, like a consumer, and I'm going to use an await method here. Call this get async. I'll print like async get. Okay, so there's my consumer like that. Await get. Oh, async. Oh, exactly right. Now you get a bonus point for that. Yeah. No, this is like no. Like this is a big problem with async. If you forget that magic word async, you know, it's like you just die. Okay, so no, you get a bonus point for that. Okay, so you have this a consumer thing. So let's make this make the QE object here.
Does the indent on async def a consumer need to be under def or under
the
indentation there?
Oh, the indentation like here. I don't know what this. I don't know what the style guide says on that. Like you're thinking like it should be all the way over. Like
I'm just wondering.
I don't know.
All right.
I'm gonna keep it at 4,
right.
just to I don't know, please the Pepe gods a little bit there. Okay, so we're gonna do this QE thing like that, and so here's how this is gonna work. I'm gonna go ahead and make like that producer again. I'm gonna say okay, well the target is producer. The args are this like queue thing like that. Keep in mind that that's thread code. Okay, that's not async IO code. But then what I'm going to do from here is I'll go ahead and get like the event loop from async IO, and then I'm going to do this run until complete a consumer on queue. Let's fingers crossed that this is going to work here. So what you have going on is you have so you have a thread basically feeding data to async IO through this kind of weird, crazy like queue thing. Okay, this like non-blocking queue. I mean, this is great. I mean, it's like I can't emphasize enough like how much async IO loves this like non-blocking stuff. So if I come up here, like the fact that you're working with futures, like here, this sort of thing, async IO looks at that and it's just like loves it. I mean, it's like wants to like blow a kiss at the future thing. All right, so don't ask about that. Okay, now the thing that I really don't like here. Okay, so got this. Okay, so we have queue going between like thread and async IO. I don't like the put sync, put async stuff. That's just that is just too hard on the brain to like remember that. I don't know. It's too explicit. It's like too explicit is not as good as explicit, right? In the Zen of Python there. So I'm going to go down this kind of interesting little digression here. I'm gonna write a function. So it's a little backstory on this. So I met James Powell kind of at the corner of like 7th Avenue and like 41st Street last night, and he gave me like some secret information. And the secret information he gave me is you could write like a from coroutine function, and like all good magic, you've got to do frame hacking. There's always this is a way of reaching into like the stack frame of like functions that called you. And I'm going to do this kind of interesting frame hack. Not import. This is this is a return statement. Python, you're supposed to know that I'm returning. Okay, where I'm going to do just that. Don't ask where the 380 comes from. It's just Well, I mean, it comes from the C source code. So just Ignore that. Ignore that. Now, using that, you can kind of do this interesting trick. I'm going to write a function called which pill. What was that? Are you heckling? Okay. That essentially says, okay, if you're coming from a coroutine, I'm going to print out the word red. And then if you're not, I'm going to print out the word blue. Okay. And then using that, I'm going to write a normal function that just says which pill, and then I'm going to write an async version of that called async def aspam. Does the same thing. Okay, so you have two functions. They essentially call the same function. The only difference is one is async, one is not async. If you call the spam function, it comes back and says, okay, you're blue. If I make an event loop, let's do that. Make an event loop, and then run. Okay, a lot of typing to get this to work. Run until complete. Aspam, like that, comes back and says red. Okay, so you can already see it's like, okay, that's kind of insane. It's like you essentially have a function which is doing a different thing depending on how it was invoked. Like if you're inside an async function, you get red, and otherwise you get blue. Okay, so where is that going? Well, what you can do with that is you could unify these two functions. Like I could write a general get method, and I could say, well, if you're coming from a coroutine, return the get async one. And I have to do a self on that. Okay, so we're gonna go down one path, one way, and then otherwise we're gonna do the sync version. We're gonna do the same thing down here. So we're gonna write a put method. Again, we're gonna do this thing, like if you come from a coroutine, we're going to return the self put async, like that. Otherwise, we're going to async, yeah, definitely. I think if I forget the async there, my laptop will like collapse into like, I don't know, singularity or something like that. Okay, so you're gonna do this. You have these kind of put and get methods on there, and what happens there is you can kind of go back to what you would think of as like kind of a normal queue, right? It's like, okay, the producer can do get, and the consumer can do get. The A consumer can do get. I mean, essentially the interface and all this stuff is going back to its sort of normal queue-ness, if you will. I'm going to make an async producer just for completeness here, and you'll see why in a second here. Okay, so you've got asynchronous producers, synchronous producers, and so forth, and they all just kind of use the get and put. Essentially, I'm thinking of like this Python mantra. It's like there should only be one way to do it. Get and put. That's how you do queues. That's the one true way to do queues there. And if you go down that approach, it suddenly becomes really kind of awesome, actually, right? So you can make this this queuey object where you could launch like a thread. You could say, oh, okay, let's have a thread where the target is producer, arguments is equal to Q10. Okay, let's launch that, and then I could go ahead and launch like my my asynchronous consumer on this thing. So I could say, well, let's run and run until complete a consumer queue, like that. You got that. So you have like going from like you basically have a thread going to async at that point, and you can kind of go the other way around too. I mean, I could let's go ahead and reset the queue here just to be safe about it. I could make a thread where the target is the consumer. Okay, so this is the threaded consumer, like that. And then I could run like the event loop where I have like an async IO producer. But keep my fingers crossed that actually works. Okay, so you've got it kind of going both ways. It's like async can talk to threads, threads can talk to async. It's through this queue object. It is actually much more interesting than that because these functions actually, they don't really care what kind of queue you're working with. It turns out that if you were just doing normal thread programming, okay, keep in mind, this is the thread queue, not my weird queue that I just just hooked up there. If I wanted to, I could use the thread code with that. Like I could say target is equal to producer, args is, you know, Q10, like that. And then I could launch my, my consumer code. Works fine. The reason it works fine is I'm using get and put. That's how it threads what queues do. Turns out you can do the same thing with the Async IO queue. Async IO actually has its own queuing object as well. So this is, you know, this is you could make that. Keep in mind this is the async queue, and I could make a task like that. So you could. I don't know whether I want to run that or not, but it's like you basically have the event loop. I guess I could make like a, well, I don't know. We'll do a create task on that where we'll make like the consumer on queue. And then I'll run until complete on the a producer. So we're kind of in the asynchronous world with that. Okay, well, not gonna. That should be 10 is what it should be. Okay, just typing it wrong. So all of this is it's like, well, okay, that's, I don't know, it's pretty intriguing. Got this queue. It kind of works both ways. Kind of goes from async to sync, sync to async, and so forth. And why am I doing that? I mean, it's like, what is this about? Well, I mean, you can look at this and say, well, like, why are you making your own queue? Turns out that async and threads don't really cooperate that well in a lot of contexts. It turns out in the async world, if you want to talk to threads, there is a way to do it, but it's kind of this low-level thing. What you have to do is basically launch things out to like a thread pool or something. And what you would do is maybe do like a, I don't know, like run in an executor or something like that, and then do a queue get on it. This is something how you run like a thread in an async IO. And frankly, I just kind of look at that, and it's like, it just bums me out, honestly. I mean, it's like we could go on like a big rant where it's like, you know, the fact that async IO and threads are kind of this weird separate world. I'm not going to go on the rant, because I think like Grumpy Cat is basically says it all. It just kind of makes me sort of bummed out to see that, and really kind of gets at the heart of maybe what this talk is about, which is the separate worlds of async and threads. I mean, essentially, if you play in this space, it's like there's all this stuff in the async world where you've got, you know, Async IO, and you have AIO HTTP, and like all these libraries being written for Async IO. And then you've got the threaded world where you have all this stuff like, you know, requests and SQL Alchemy and Django and Flask and all these different things. You have these like two worlds. And I think that the thought is, you know, could those worlds maybe interact a little bit better? And, you know, the thing in this talk, if this queue thing, is kind of an experiment in that. It's like, could you bridge those worlds in a more interesting way? And what might that look like? So, so that is it. Let me switch here. Thank you for inviting me to New York. Talk is about kind of this interesting idea, and the title, The Other Async. It's really about making threads and async play nicer together. So, thank you very much. I'm Dave Beasley. All right. We'll see if that worked, doing the talk backwards like that. I don't know. We'll see. We do have time for 2 questions. I've been told a question way in the back in the red shirt.
Well, first of all, I was wondering, what was the justification for making a wait require the wait for wrap future as opposed to being able to just wait for future object?
Okay, so
why is it called futures as opposed to say promises?
Okay, yeah. So the question is, why do you have to do all that wait for wrap future business in async IO, and why is it called future, I think. So the answer on that is that the async IO and threads are just totally different universes in the Python world. That future that I used here is from the threading side of Python. It's used for thread queues and pools and processes. Async does not know how to work with that natively because that result method basically blocks. Like when you call result on a normal future, it blocks. And because it blocks, it would actually just kill the entire event loop underneath the covers. So what is happening with all that wrap future business is it essentially takes like that, you're going to be horrified, by the way. It takes that thread future and it wraps it in a way that when the result gets set, it basically writes a byte of I/O onto a loopback socket connection. Like it actually like writes a byte of I/O, and then the async IO library recognizes that and says, "Oh, there's some I/O that happened." And then when it's done with that, it can actually unblock that future and get the task to run again. It's a total kind of behind the scenes thing, but it has to do that to sort of turn it into an I/O operation. The other part of the question, why is it called future instead of promises? I don't know. It's what they chose to call it. So let's see, do we have any more? Okay, one question here, and then we're done.
So, in that question, in the function to determine whether it's a coroutine or not, to me, aside from checking the stack, what bothered me about it is that you're kind of doing type checking on an object. Is there possible use of polymorphism that could be used to implement something like that?
Yes, the question is, there's some kind of polymorphism to check on the async sync thing. I'm not aware of that. I mean, it's kind of weird because it's like they're basically in these like two different worlds that are existing, and even that frame hack is sort of dicey. I mean, I would personally like, yeah, a little dicey. I mean, I think it would be actually cool for them to build that into Python. Just like, can you tell whether you've been invoked from a coroutine context or not? Would be a useful thing. I mean, I don't know why they couldn't do that. I mean, as opposed to having to do like a magic frame hack, but I think the really big thing is, just this idea that you could have the same API on something used in a different way is sort of an interesting thing. So, and
What's your second favorite Python module?
the second favorite Python module, I don't know.
All right.
All right, that's it. So thank you very much, and we'll.